Okay, so welcome everyone. I'm going to take a look at question 14, and this is from chapter 10 if you have the full version of the textbook. If you've got the sort of abbreviated custom edition from BCIT, it would be chapter 5. Okay, but again, if you are looking on the website for this textbook, for any sort of materials, it would be under chapter 10. Let's take a look at question 14, and let me just grab it, and then I'll put it onto Excel so that it's there handy. Let me just copy that, open up Excel, and let me just insert and a text box. Okay, let me just pop that in there. All right, and I'll just make this a little bit larger so it's easier for you to see. Okay, so we got the two questions here. All right, so part A and part B. Okay, so let's take a look at this question. So we're looking at demand for tennis balls. And take a look here, it's normally distributed. All right, so again, if you remember before, we can describe any normal distribution. Remember, it has that bell shape to it, and it has two attributes that we need to know about, which is the mean, which is the middle of the distribution, and the standard deviation, which shows you the spread. So the bigger the standard deviation, the more spread out it is around the mean, and the smaller the standard deviation, that means the observations don't fall that far from the mean. It's more of a sort of a spiky bell shape. Okay, so the club gets a profit of $50 per case. So they want us to simulate 52 weeks of demand. So let's put some demand over here. So we'll just put this as week. All right, and then we'll just go week 1, week 2. And that's all we need to give Excel a pattern. And then we go from the white cross to the, which is, I guess, the puffy white cross to the black cross. And then just click and then hold and sort of stretch that down. Just got to go down 52. Okay, here we go. All right, so that's 52 weeks. There we go, 52 weeks. And the next one over, we're going to make demand. Okay, so one thing to note about, I guess, in general, this whole idea of building a simulation, it's built on this random variable. So let's take a look here. So it's equals and then RAND open close bracket. All right, so again, RAND open close bracket. And what that does is it chooses a random variable between 0 and for, pretty much 1, right? And that random variable, if you remember from before, probability is in between 0 and 1, right? 0 means this event is just not going to happen, all the way to 1, which means that it's for sure going to happen. All the way to, somewhere in the middle, like, 0.5, if probability is 0.5, there's a 50% chance of this event happening. So take a look here. So this is just a random variable that I generated, so 0.655889. Okay, but if I go into an empty cell and just press delete, you'll see that it just sort of recalculates, right? So anything between 0 and pretty much 1. All right. So this random variable can mimic for us a probability. All right. Now, it's not going to be some sort of haphazard numbers that will be generated. It's going to generate based on a distribution. So one of the things that you need to know for simulation is, okay, what are we simulating? And in terms of its distribution, in terms of past data, what kind of distribution is it most like? All right, so you'll see, and this is the beauty of Excel, is that different phenomena can be represented by different distributions. Okay, so for example, if you remember from before, we had the norm inverse, right? So that was equal, and that was the norm inverse from before. And we had a probability, right, which was the percentile. So for example, if I go 0.2, so give me the 20th percentile for these tennis balls, cases of tennis balls. And then I would put in 35, which is the mean, and I would put in 5, which is the standard deviation. So what I'm asking for is the 20th percentile. So it's going to give me a number, and that number is the, how many cases make up the 20th percentile. All right, so that gives me 30.79, and you can't have 0.79 of a case of tennis balls. So it's roughly equivalent to 31. All right, so if I was going to show this to you on a diagram, take a look here. All right, so again, 35 is the mean, right? And again, if we shaded in this half, that would be the 50th percentile. But what we're looking for is the 20th percentile, which is, what number of, in terms of cases of tennis balls, would cover 20% of the sort of observations that we see. So what is this sort of number here that accounts for, say, the 20th percentile, or 20% of the observations? So if we look over back here, we would see the number would be 31. So we put 31 here. Okay, so 31 and below, again, all those types of cases less than that would cover that sort of 20, would cover the 20th percentile. Now we can also take a look at, something like, what is the 90th percentile, right? So you can see 90% of the area is shaded in for the 90th percentile. And this question mark here, what is the 90th percentile? How many cases would capture 90% of the observations? So we would do that again, plug that in. And we can take this equation, copy it, double click. Instead of 20%, now we would just put in the 0.9, right? So now we're asking for the 90th percentile. And again, that the 90th percentile is to the right of the mean, and the mean is 35, so it must be some number bigger than 35. And as you can see here, it's 41.4. And again, we round to the nearest case because we can't have 0.4 of a case. So we would go and look here, and we say that that would be 41. So 41 cases captures that sort of 90th percentile. In terms of 90% of the observations in terms of demand would fall at 41 and below. So what we want to look at here is in terms of interpreting. So what I'll do is I'll get rid of demand right here, and I'll just title this random number just to show you how this is sort of being set up. Random number, and then we'll just show you demand. Okay, and then I'll eliminate the B one here, the B column, after we show you some of the mechanics. So R, A, N, D, and then open close bracket. All right, so again, it's choosing a number between, as you can see, between 0 and 1. Right, so it's randomly choosing that number. But again, if we bring it under the normal distribution following this, it's going to follow this distribution because we're going to set that in. Now what you can do is we can copy that down. Just give this a double click, copy that all down, and then we can have for the demand, say, and this would be norm inverse like we had before. And we got the probability. And remember, this random number can substitute in as a probability. So we pop that in, say, check that one out. And 35 and 5 cases. All right, and then we can put that in, and we could sort of copy that down. Okay, now, as you can see, we want it rounded to the nearest case, right? So it says make all demand values integers in your model. So round it to the nearest case is what they're saying. You can't have like here 0.71856 of a case. They say take that and round that to 32. So we'll show you how you do it. So what you would do is just go into the formula and just, luckily this is very intuitive, right? For rounding, it's just round, right? So just type in round, and then of course make sure you spell it right. And then put it in brackets, and then a comma, and we'll round it to 0, so there's no significant digits after that. So we're rounding it to the nearest whole number, and as you can see, and then I'll just copy that down. Okay, and you can see it rounds it to the nearest number. So what we've done is we simulated demand, but it's not just sort of willy-nilly. It's following this distribution that we said, hey, it's normally distributed with a mean of 35 cases and a standard deviation of 5. So we've just simulated demand. So instead of having to wait, for example, 52 weeks, we can say, well, if it's following this, we can make a simulation. And again, we'll show you, in this case, we'll make a simulation so that it's capturing like 200 years of supposedly doing this sort of experiment over and over again. Because what we want to do with a simulation is we want to say, on average, what's our best decision? Well, we would say, well, let's replicate reality if reality is still following this distribution to give us an idea of what is the sort of best decision to make. And again, that's the power of a simulation, is that it's replicating I guess, supposed data that would take, in some case, many, many years to do. Okay, so having this sort of, and of course you can see here, if it's 0.544, it's pretty close to, in this one here, 0.544 is pretty close to the 50th percentile, which is the mean. And you can see the mean is 35. So that makes sense that that is 36. Okay, and look at how close this is, 0.5288, which is close to the mean, and that's 35. And you can see for, I guess, some larger numbers, all right, so you can see for here this 93.8, that's pretty much the 94th percentile, which is the demand of 43. So you get some idea of that. Now we don't need this column here, so I can build it right in. So instead of just referring to B2, I can just type in the random. So I can just go RAND, open, close bracket. All right, and again, I just broke it down into that step just so you can see how it's interpreting that number. So it's interpreting that number as a probability and then spitting back a demand associated with that probability following this normal distribution that we put in there. All right, so again, and I'll just sort of copy that down, and you can see that it's, and now I don't need this anymore because it's not looking to this column for the probability. As you can see when you click, it's already sort of built in. All right, so I can just take this and I can delete, okay, and we just pop that over. Okay, so let's take a look here. So simulate 52 weeks of demand. So we did that. And in terms of our coloring, we can color this. So anything with the sort of the simulation part is in a light blue. Okay, the brighter, the lighter, the better. And so let me make this even a little bit lighter, just because the numbers are dark, and then we can still, that still pops up. All right, and again, one of the reasons why we do this is we always make whatever we produce for an audience. All right, so whether it's for your clients, your boss, your supplier, your coworkers, the more that they can sort of see and understand what you're doing, the better. And as I've told everybody many times, if you're the only one that can do it, then you never get a vacation, you never get promoted, right? So, because you're just too valuable, you can't go. Okay, so it says simulate 52 weeks of demand and calculate the average weekly profit. Okay, so we've got to figure out the profit. So the club gets a profit of $50 per case. All right, so again, we pop in the profit there. So we want to pop in profit. Okay, now in terms of numbers, we probably want to have a profit per case, profit per case, which they give to us, and they said it was 50 bucks. All right, so we put that there. So we'll put that in as 50 bucks. So that's $50. And let's draw people's eyes to it, right? So other people that are looking at this can understand it. And this is an input. And in terms of simulation, you want to have that in bright yellow. So that's the input that are there. Again, so as we see, we got the simulation portion is in blue to draw our eyes to it. And in yellow, we've got, as you can see here, the input. Okay, so that's profit per case. And again, when we build this, we want to take this demand and then multiply it to this cell here. So we never want to plug in 50. We want to have it referring to a cell. That way, if we do change the profit per case, we can just pop that in and everything changes. We don't have to go through our formulas because it's already updated. So H5, as you know, we're always going to be referring to that. So we want to make that an absolute reference. And on my computer, it's function F4. All right. And then we can pop that down. Now, this is a profit in dollars, so we can format this. So let's format the cells and just say, hey, this is currency. So make it as money. Okay, round it to the nearest cent. Okay, so they said, okay, so weeks of demand, calculate the average weekly profit. Okay, so what we got to do is we got to take all these profits and just get the average of that. So what we want to do is we want to put this together, and we want to call this, in terms of one replication. Okay, so they want the average profit, but we've only based it on one replication. So let's have it sort of based on, I guess we'll put it as one replication. All right, and so we want average profit. All right, so we have that there. And then they're saying, what is the probability that weekly profit will be $2,000 or more. So let's pop that there as well. So we just do this probability, and this would be the profit is greater than or equal to 2,000. Okay, so we have that there. So let's pop this into a table, draw our eyes to it, and let's put this in as a title. And let's put this in bold, just so it pops a bit more. Okay. And this is going to be our output. We want to have that as green. All right, so we just highlight these two as being green. And again, the lighter the green, the better, because the numbers are all in black. So let's make this a bit brighter. There we go. All right, so it's nice and bright. So average profit. So what we do is do equals and then average. And then we just grab all these profits. All right, so if we do this over and over again throughout the year, we would end up with an average profit of, it looks like, about $1,751 approximately. But notice, because it's based on the simulation, if I go into empty cell and press delete, all of my random variables recalculate, and you'll see that the average profit changes based on that, but it's not changing too dramatically. All right. Okay, so next we have the probability profit is greater than or equal to 2,000. Let me just close that bracket. There we go. All right. So what we want to do for that one is we want to use a count if. All right, so we would count if. All right, we just follow along. So it says, show me the range. So I said, take this range. All right, so go through this range here and count if any of these are 2,000 or more. That's what we're asking it to do. All right, so that's the, so we're saying scan this range, and the criteria, we just put that in quotes. We would say greater than or equal to 2,000, and close off that bracket. So we're looking for numbers that are greater than or equal to 2,000. Okay, and you can see that they found 15 out of the bunch. All right, and we could just, so 5, 9, 7. You can see when it recalculates the probabilities, okay, when it recalculates the random number, you can see that there's some variability in there. But again, that's not a probability. It's a probability if we divide it by the total number, and total number is 52 weeks. All right, so it's saying, you know, how many of the 52, which would give it a probability. All right, so that's in dollars there, so I need to take this and format it so that it's a number. All right, so because it says a currency, right? So there we go. Okay, so again, this is saying that 13.46% of the time we're getting greater than or equal to 2,000. And again, we can just pop this and you can see how it changes, right? And again, the reason why it's changing is that the demand is changing because the demand is based on those random numbers which recalculate. Now I could take this and base it on 200 replications. So let me just copy this whole table. Okay, we can call this based on 200 replications. All right, we talk about how we can do that. Okay, so let me move this out of the way. So what we would do is we would, instead of doing this whole sort of thing 200 times, which can get ugly and cumbersome, what we can do is we can seed a data table with this information here, and it could say, well, we can take what you put there and we can manipulate it and produce it for 200 different times. So remember, this is the average profit for a year. All right, and we can do it almost as if we did 200 years worth of data, which is, you know, kind of amazing. And that's what the simulation will be doing. So we would have a data table. All right, so we have data table. We just call it data table up here, and then we would have run, and then we would have 1, 2. All right, and that's what we need for a pattern. All right, and then we could just stretch that down 200 times. All right, went a little bit too far. There we go. So we can have 200 runs. All right, now what we need, and here we'll have the average profit, all right, for each year. And the next one would be the probability being greater than or equal to 2,000. Okay, so we want to make this, let me just pop this into bold, make this bold, and there we go, just to, and now we want to seed this, and what we have to do is we have to seed this with the average profit. So the average profit here, right, so it's going to be this value, so you can see that this value is the same as this one, so that seeds it just so it figures out what it needs to do for all the rest of the runs. And also the probability would be equal to this one here, right, which would start it off. Okay, so you can see that 0.2308, 0.2308, you can see it's the same. So what we want to do is, and be very, very careful here, and that is to make the data table work, all we have to do is highlight those runs, okay, and the sort of input data, not the headers. All right, so if it's not working, the first thing you should check is make sure that you haven't included the headers. The headers should not be included. All right, otherwise it won't work for you. All right, so again, just make sure, you can see I'm just highlighting this information, and you can see the headers are not in there. So what I would do is click on data, and then what if analysis, and then I would use data table. Now we're looking at this in terms of columns, filling up the columns. So we will put this here. Now in terms of what we're using for input cells, we need to find a blank input cells. And what I'm going to put in here is just AA1. There's nothing special about AA1. It's just that I know that it's way to the right, way over here. And I know it's, this is a fresh Excel sheet, so it should be empty. So we want to find something that for sure is empty, and that's something far to the right. So it doesn't necessarily need to be AA1, but for me to be on safe side, I'm just going to pick AA1. And it needs to have that sort of blank area for it to work and go that in terms of inputting it. Okay, so again, there's nothing special about it. It's just AA1 is something that I know is blank. All right, so pop that in, and then you can see all the various runs and all the various average profits and probability. So this is output as well, so we need to highlight that in green as well. And that's going to be helpful for anybody, again, that we're working with, so that they can sort of figure out what we have. Okay, and then I can just making this into some nice tables so it's a little bit easier for our eyes to see. There we go. Okay, we could probably do with a line in between, so we could probably do with a nice line in between just so we can more easily see it. Okay, so what we would fill in for here based on 200 replications is we take the average of all those sort of average profits. We take the average of those. All right, so we grab that there. All right, there we are. All right, so L3 to L202. And we would take the average of those probabilities. So average, all right, so that's going to be M3 to M, and I guess it would be 202. And let me verify, make sure I'm grabbing it all. Okay, good. I'm grabbing everything there. And then we just close that off. I take the average of that. Okay, so we got the probabilities there. So again, notice what we have is these are runs. So this is basically like doing what we did over here. All right, doing what we did over here, but we make it a lot more compact. So instead of building a whole pile of numbers, 200 of them, we sort of compacted it. All right, so again, so once we told it this is how it works, it basically did many, many runs. All right, so, and again, there's 200 runs, so we're taking an average as if we were doing 200 years worth of sort of running this business, which is again, would take a lot of time in real time, but this would give us a better idea in terms of what are the sort of best ways to go about this in terms of what we can expect. But one thing that we'll notice is this is an average of average yearly profits. So it's not going to vary that much because for one, it is an average of monthly profits each one, but then we're taking the average of those 200. So anything that is extreme is going to get washed away by all the other averages that are there because we're taking the average. So any sort of large value or small value is going to get washed away. So anything that's extreme should get washed away. And it should be, again, less variability. So take a look at this number here. And if I just go to an empty cell and just press delete, it shouldn't change too dramatically from, looks like around 1,750 or so. All right, so it shouldn't change too much from it. You'll see it's not varying that much from 1,750 or so. Okay, and take a look at the probability. And again, the probability is an average, okay, based on the probability for each year. All right, and again, it did it for 200 runs. It'd be like as if it did it for 200 years. And since it's taking the average, it shouldn't move around that much from around 18.6%. So I'll go into a cell and just have it recalculate. All right, so it's hovering around, 18.5 or so. There's a few off ones, but again, it's not hovering too much. But notice this one here, this is based on one replication, the average profit. So it should have more variability, right? So if we take a look at that, 775, 749, 18, 17, it's moving around quite a bit. And same thing for this one here in terms of the probability. It should be moving around quite a bit more. If we'll look at that, 17, 13, 46, 23%, 15%, 25%, 21%, so 11.5%. So again, it's veering around, whereas this one was closer to around 18%. So again, if we want more accuracy with our simulations, it's better to base it on quite a few runs, right? So if I wanted even more accuracy, I can go from 200 runs and I could do another one with, say, 500 runs and take the average of that, and that will give me some more accuracy. Okay, so let's sum up with our question that we have here. Okay, so what we've done is we've simulated 52 weeks of demand. That's what we did here. All right, and again, if we want more accuracy, we can use data table, right? A data table will take what we did here and they'll do it essentially 200 times, right? So instead of running this whole thing and doing it 200 times, which can get cumbersome and messy, all right, we're doing and using data table. And remember, when we're using data table, you can see that this number here is the same as the first one, and this one here is the same as the first one, but it takes how we did this in terms of the mechanics and replicates that 200 times. And remember, to do that, I've got to put all the runs down, all right, and I've got to get the seeds in there, and then I'll highlight that. So remember, when you're using data table, you don't run and highlight the headers, because if you do, it won't work. Okay, and again, when we do in terms of data table, just remember that we're using the column because we're filling down the column. And again, I used AA1 because that was input cell. It needs an input cell, and it needs something that I know is blank, right? So we know that it's blank in that area there. Okay, and you can see when I click on the any of the numbers there, it's referring to this table AA1, which again we know is something that's blank. All right, so that's what I'm looking at for question 14.